So in analyzing scan results, you can see that indeed some ports are open when we turn off the firewall. But when we turn on the firewall, you can see that all 1000 ports are filtered. This firewall doesn't have a special role since it blocked all traffic. So the next few methods that I want to show you will not work on regular machines that turn on their firewall, and also does not accept any type of communication. But if firewall rules are applied on some servers or machines, and that is because they need remote access or need to communicate with other machines, then these few options I'm about to show you can be tested on such servers or machines to know if they have any vulnerability we can bypass. So we'll make sure our firewall is still turned on, and we can close that for now. So the first option we are going to try is -F. So we're going to replace this with -F. So what does this F stand for? You can see here it stands for fragmented packets. This is the option that causes the requested scan, including host discovery scan, to use tiny fragmented IP packets. That is the word. The idea is to split up the TCP header over several packets to make it harder for packet filters, intrusion detection systems, and other annoyances to detect what you are doing. But you need to be careful with this. Some programs have trouble handling these tiny packets. So if we specify this option once by adding just -F, the Nmap will split the packets into 8 bytes or less. If your packet had 20 byte TCP header, it will be split into 3 packets, 2 with 8 bits of the TCP header and 1 with the final 4 to make it 20 bits. Then you can also specify the option like this using -F. What this will do is to split the packet into 16 bytes per fragment. If you want to further, you can use this option -MTU if you want to increase fragment size. So this option does not always work, but it's good to know this because one day you might need to make use of it. Then another option we can use, which is focused on bypassing firewall and hiding your IP address, is -D, and that is creating decoy. So this decoy makes the target think that it has not just been scanned by you, but by other decoys you're going to provide during the scan. So the target IDS might report other IP address, but it will not be able to detect your own IP address because it's going to receive several IP address at the same time. So the target will not be able to detect which of the IP addresses is real or your own IP address. So you end up hiding your IP address from the target. So let's take a look at this decoy. -D stands for decoy, and here we're going to use at least 5 IP addresses. And see this, cloak a scan with decoys, causes a decoy scan to be performed, which makes it appear to the remote host that the host you specify as decoys are scanning the target network too. Thus, the IDS might report 5 to 10 port scan from unique IP addresses, but they won't know which IP was scanning them and which were innocent decoys. While this can be defeated through router path tracing, response dropping, and other active mechanisms, it is generally an effective technique for hiding your IP addresses. So you're going to separate each decoy host with commas, and you can optionally use ME uppercase as one of the decoys to represent the position for your real IP address. So it means that we don't provide our real IP address here. Instead, we put ME in place of our IP address. So if you put ME in the 6th position or later, some common ports scan such as Solar Designer Excellent Scan Log are unlikely to show your IP address at all. If you don't use ME, Nmap will put you in a random position. You can also use random to generate a random non-reserved IP address. So what it means is that we're going to settle for this uppercase ME. So let's go back to calling. This is our Windows 10 IP address. So aside that, we're going to add other decoys, which is regarded as IP address. This is my Windows 10 IP address. So I'm going to add the first decoy now. 192.168.232.125, comma, add the second decoy 192.168.232.128, and the third decoy 192.168.232.130, then comma. Now we're going to add our real IP address using ME. So this ME becomes our real IP address, which is the Kali Linux IP address. Then lastly, this is the target IP address. So what this command will do is that it's going to use all these IP addresses to scan our target, including our real IP address. And here is the Windows 10 IP address. So I'm going to send now. And of course, this is not going to work, but you get the idea. So in case you're scanning the target that is inside your own network, this is how you do it. But if you want to scan target that is outside of your own network, then you need to use this option. I'm going to specify here Nmap Decoy RND, which is random number, and you specify how many random numbers you want to use. If it's 5, you place 5 here. Then you're going to place your target, such as 192.168.232. Then you can use the steel scan for this. So this is how to perform that scan which is outside of your network. And if you're scanning a target within your network, this one will work. So let's move on to the next option we have here, and that is IP spoofing. You can take a look at what it stands for: spoof source address. In some circumstances, Nmap may not be able to determine your source address. So another possible use of this is to spoof the scan to make the target think that someone else is scanning them. You can use this option, and you try to impersonate an IP address. For example, you can use 8.8.8.8 to scan a specific target. The problem here is that you won't get the scan result back, because the scan result will be sent to the IP address you specified here, which is 8.8.8.8. And for this to work, you must specify -pn. And what this -pn we do is to specify that all hosts are online. And sometimes we must also run this option with E-A. E is used to specify a network interface. So you can simply use ifconfig and check out the network interface you're using, and you can specify that here like this. Another scan that Nmap has is to specify the -G option. You can specify the source port with this -G option. This sometimes helps bypass firewall. A network administrator might set up a firewall, and the rules will say that only traffic from a particular port is allowed. And to the network administrator, attackers will never be able to discover what port that will be. But if an attacker performs a scan and send packets from that port that is allowed from the firewall rule, the firewall will be bypassed. So we're going to use -G to specify that, and we pick any random port number. Another thing that will help you bypass firewall is changing different scan types. So this is what I mean. In case you perform a SYNC scan and is dropped by the firewall, you can also perform a fin scan. So Nmap has different scans you can perform, but one good thing is that we are in the age of artificial intelligence, so you can take your questions to AI, and AI will give you the kind of scan to perform. AI will give you the code for the particular scan you want to do. So that is the beauty of having AI in this age. So never be worried or bothered about Nmap scan. Be specific. Tell ChatGPT, this is what I want to do, what code do I need, and this is my target IP address, and input everything there, and ChatGPT is going to give you what you need for that particular scan. You can as well interact with ChatGPT while scanning, and ChatGPT is going to help you all along until you find your desired result. So everything we've been saying about Nmap scan can also be combined with what we call timing. We can specify a particular timing which Nmap will use to perform our scan. Here it says set a timing template. We have options, and the numbers are 0 to 5. The template names are paranoid 0, sneaky 1, polite 2, normal 3, aggressive 4, and insane 5. The first two are for IDS evasion. Polite mode slows down the scan to use less bandwidth and target machine resources. Normal mode is default, and so T3 does nothing. Aggressive mode speeds scans up by making the assumption that you are on a reasonable, fast, and reliable network. Finally, insane mode assumes that you are on an extraordinary fast network or are willing to sacrifice some accuracy for speed. So the problem with the paranoid and the sneaky mode, as you can see here, we have about 6 of them. So these first two, because it wants to scan and doesn't want to be detected by IDS, it takes a lot of time to scan. So like I said, Nmap is a big tool, and there are so many things we didn't cover in this video. So take your time to go through it. That's why I also use the manual to show you how you can go about it. So always type manual Nmap or man Nmap and see what you can do with the options you can find here. That's all for this video, and I'll see you on the next one.